인트로 나가는 거 아닌가요? 나갔습니까? 네, 아이고, 네. 어쨌든 저희가 이제 이번 시간이 또 저희 마지막 그 촬영이 될 것 같으네요. 좀 저희가 처음에 시작할 때 좀 경험도 없고 그래서 좀 여러 가지로 좀 기계적인 또 기술적인 좀 실수도 좀 있고 했는데 여러분들 좀 많이 이해해 주시고 양해해 주시기를 부탁드리겠습니다. 이제 좀 숙달 되려고 하니까 네, 끝이네요.
Hello everyone. Finally, we just got to the final session of our YouTube live streaming. Actually, from the beginning, we have a lot of technical issues and problem because of our lack of experience of this type of lecturing. But we are almost get familiar with this kind of a situation and a procedure. But it's already the end of the session.
저희가 지금 제작한 동영상과 또 지금 유튜브 방송이 그 특히 개도국 처음 냉동 공조를 시작하는 국가에서 많은 도움이 되기를 희망합니다. 또 기존에 하던 국가도 도움이 됐으면 좋겠습니다.
So I hope by utilizing our YouTube video clip and the YouTube live sessions to help a lot of countries such as the developing country and the other country who are engaged in our skills, refrigeration and air conditioning.
이번 시간에 저희가 이제 여러분들과 함께 할 그 동영상은 저희가 총 12편 중에서 8차시 8번째부터 12번째까지 총 5개 동영상을 연속으로 보면서 제가 중간중간 좀 설명을 드리는 시간을 갖겠습니다.
So today in our last session of the YouTube live streaming, we are going to handle the 5 video clips from number 8 through number 12, in totally 5 video clips.
5개 차시 그 영상이 주로 이제 고장 수리 관련된 내용이거든요. 그래서 이제 8차시 전기 고장 수리 찾기와 수리부터 시작해가지고 마지막 12차시 이제 다시 기계 고장 수리를 이제 다시 원상 복귀해서 시운전하는 것까지. 그래서 고장 전기 기계로 나누어서 고장 수리를 찾고 수리하는 과정을 오늘 시간에는 이제 여러분과 함께 하겠습니다.
So in these 5 video clips, we are going to handle the part about the fault finding task and the repair task. So from the video clip number 8, we are going to conduct the fault finding task, which is divided into the electrical fault and the mechanical fault. After that, we are also going to deal with the part about repairing the fault. And lastly, in the video clip number 12, we are also going to deal with the commissioning part at last.
지금까지 7차시까지는 저희가 좀 디테일한 기계 제작과 전기 제작, 시운전 이렇게 선수들이 좀 훈련하고 반복 숙달하고 그 절차를 외우면은 할 수 있는 과정인데 사실 고장 수리는 이게 좀 그렇게 우리가 훈련을 그런 식으로 집중해서 할 사항은 아닌 것 같고 좀 그 장비의 어떤 면을 이해해야 냉동 전체를 좀 이해해야 할 수 있는 그 과제인 것 같습니다.
In my opinion, in the previous sessions, which covers the video clip from number 1 through number 7, is about fabricating the refrigeration system or the conduct the test or the conduct the commissioning. So it can be familiar with those kind of a procedure by repeated training to the competitor. But in case of today's session about the fault finding and the repairing task, it can be a little bit different from the previous one because the competitor should understand the overall understanding about the air conditioning units and our skills, refrigeration and air conditioning.
그래서 제가 지금 다른 시간에 비해서 조금 많은 말씀을 드리는 이유가 저희가 이제 국가대표 선수가 제가 이제 뽑히고 나면은 훈련을 시켜야 되는데 특히 이 고장 수리 부분에서 어떻게 훈련을 시킬까? 왜냐면 고장 수리라는 게 수천 가지가 이제 나는데 그걸 다 선수한테 어떻게 이렇게 지도하는 것도 어렵고 해서 제가 이제 고민하다가 이제 만든 프로그램이 이제 선수한테 고장 수리를 찾는 그 어떤 요령 그런 거를 좀 훈련을 시키자는 의미에서 이 프로그램을 만들어서 선수들에게 지금 훈련을 시키고 있습니다.
Actually, the reason why I highlight the task about the fault finding and the repairing the fault is it is a little bit hard or difficult part to train our competitor, the competitor, especially the Korean competitor. So I just finally designed the specific training program specified for the fault finding and then repair the fault task. So according to my training program, I just focus on the skill how to find the fault in the air conditioning unit.
지금 이제 너무 오래 지나갔죠 시간이. 그래서 이제 시작을 하겠는데 이제 8차시는 전기 고장을 찾고 이제 수리하는 과정인데 저희가 이제 훈련을 할 때 바로 이제 뭐 에어 컨디셔닝 이런 거를 이제 수리를 찾고 하는 것보다는 기본적인 어떤 시스템을 가지고 그걸로 이제 훈련을 먼저 하고 기초적인 훈련을 하고 찾는 훈련을 하고 그게 숙달이 되면 이제 실제로 제품을 가지고 찾는 그런 동영상을 한번 제작을 했습니다.
So now we are going to move to the video clip number 8 for giving you the explanation and the instruction about the fault finding and the electrical part. So in my opinion, it would be the best to have a few times of practice in the simulations equipment for finding the fault. After that, the competitor feels comfortable with those kind of tasks. Now they can utilize the actual air conditioning unit for their training.
네, 그러면 이제 동영상을 한번 같이 시청하시면서 중간중간 제가 필요한 부분을 끊고 설명을 드리도록 하겠습니다.
Let us have a look at the video clip and I will give you the explanations in between the video clip.
Electrical continuity test and insulation test.
지금 영상은 아마 저희가 그 과제 모듈 3과제에서 아마 이런 그 인슐레이션 테스트하는 거는 아마 좀 봤기 때문에 좀 시간 관계상 좀 진행하면서 뒤로 옮기면서 좀 하겠습니다.
So we already give you the instruction about the continuity test and then insulation test in our previous session. So I will skip this part.
예, 이건 조금 했던 기본적으로 저희가 그 인슐레이션 테스트를 했던 부분들은 조금 지나치고 저희가 이제 부분적으로 필요한 부분으로 이동을 해서 설명을 드리도록 하겠습니다.
Let us move to the part of what I would like to give the detailed explanation.
You can identify most of electrical faults only by conducting the basic electrical circuit test. Therefore, it is very important at an actual operation to conduct the electrical circuit test before supplying power for the first time. After all basic tests are completed, reassemble the machine that were disassembled and be ready to supply power. Rubber insulation gloves must be worn to prevent electrical shock when inspecting equipment with applied power. Before supplying power, measure the power outlet voltage using a digital multimeter so that the accurate voltage can be supplied to 220 volt line and 0 volt line on the diagram. Apply the power and verify that the circuit is properly energized. Before turning on the circuit breaker, use a multimeter to make sure that the main breaker is receiving electricity. Check if there's any electrical leakage at the inner part of the circuit and if ground connection is properly conducted. After confirming the electricity is flowing into the circuit, turn on the switch to examine how the circuit is operating. Due to the electrical flow inside the circuit, the equipment must be checked with rubber insulation gloves for the safety of the operator. Check whether the power and operation lamps properly work and the light bulb for loading on behalf of the motor is operating normally. The process of finding and repairing the fault. Disconnect the power from the main electrical circuit and cut the wires intentionally to open the circuit, causing a failure. At the part where the workers has just cut the wires, the failure is caused by disconnecting the wire that is connected to the magnetic switch. To check if there occurs any fault in the machine, supply power to it again. When connecting the power, you must wear rubber insulated gloves and should conduct the power voltage test. Measure the voltage at the power outlet so that the accurate voltage can be supplied to 220-volt line and 0-volt line on the diagram.
네, 지금 요 내용을 조금 설명을 좀 드릴게요. 지금 저희 작업자가 자꾸만 플러그, 멀티 콘센트 플러그 계속 여기를 이제 점검하는 장면이 나오는데, 요거는 실질적으로 220볼트가 이제 장비에 투입이 되는지 그거를 이제 확인하기 위한 것이고요.
So in the video clip, the worker keep checking the power outlet by conducting the test. It is for checking if the 220 volt is applied to the actual system or the unit.
예, 좀 앞으로 제가 화면을 좀 이동시켜 볼게요. 여기에서 보면은 지금 L 라인이 있고 그다음에 N 라인인데, N 라인은 뉴트럴 중성 뉴트럴 선이고, 그러니까 뭐 우리가 말하면 이제 0볼트겠죠. 그다음에 L은 라이브 상해갖고 220 살아있는 전압 220볼트가 되겠죠.
So on the diagram, you can see the L line and then N line. L line is a live line, so it means the 220 voltage part, and then next to the L line, you can see the N line. It is the neutral line, and then it means the 0 voltage line.
이쪽 0볼트 라인은 예를 들어서 사람이 이렇게 만졌을 때도 어떤 데미지가 없지만은 220볼트 라인은 데미지가 있기 때문에 이걸 선을 구분해 주는 겁니다.
There is no harm or damage on the workers or competitor if they touch the neutral line. But in case of the live line, L line, it can be damaged or the harm on the physical harms on the competitor or the workers because the 220 voltage is applied.
작업자가 지금 계속 콘센트를 지금 테스터기로 점검하는 이유가, 실질적으로 우리가 원하는 220볼트가 이 라인으로 투입이 되고 0볼트가 이 라인으로 투입이 되는지, 혹시라도 이쪽 N 라인으로 220이 들어가고 그다음에 L 라인으로 0볼트가 투입이 되는지, 이렇게 잘못된 투입이 됐을 경우 문제가 생기니까 그걸 계속적으로 확인하는 겁니다.
So the reason the worker in the video clip is trying to conduct a test on the power outlets by conducting the test with the device is to check if the accurate voltage is applied to the each line's appropriate.
그럼 다시 앞쪽으로 한번 가서 다시 한번.
Let me move the video scroll
요
bars to the
장면이 이제
front.
그 장면이겠죠? 요 장면이 그 장면이고.
This is exactly the part about what I mentioned.
여러분들이 지금 동영상을 보시면서 나레이션 설명하는 거하고 화면하고 조금 이렇게 정확하게 맞아 들어가지 않고 좀 보기에 좀 다른 작업을 하는 것처럼 보이는데 그거는 그냥 참고하시면서 보시면 되겠습니다. 편안한 마음으로.
There is some delay between the actual the simulation of the worker in the video clip and the narration or the subtitles. So please understand this point when watching the video clip.
네, 다시 또 진행을 하겠습니다.
Let me move to the next step.
Before applying power, inspection for leakage and short in the circuit must be conducted using a multimeter. If you confirm that there is no leakage or short circuit, turn on the switch to check the operation of the circuit. Inspect that the light bulb for loading does not turn on properly, unlike the normal state. Using a digital multimeter, check which part of the circuit has the problem. Inspect the magnetic switch area first because the bulb is not lit and the magnetic switch is not working. If the voltage is applied to the magnetic switch, but the magnetic switch does not work, it can be identified as a failure of the magnetic switch itself. If power is not applied to the switch, it can be identified as a problem with the line to the magnetic switch. Check the electric wires and contacts connected to the magnetic switch to identify the failure. If the fault is identified, turn off the power and repair the open circuit part. If the wire is broken, it can be repaired easily. Peel off the sheath of the broken wire and reconnect it using connectors. After the repair is finished, apply the power again to check if it is working properly. Before supplying power, wear rubber insulated gloves and conduct the power voltage test. When handling electricity for safety reasons, voltage checks of the main outlet, short circuit inspection in the circuit, and leakage inspection must be carried out at every step. Train this procedure repeatedly so that it can be performed as a habitual practice. After the power is supplied, check if the electricity is provided to the circuit. If it is confirmed that there is no problem, turn on the power cutoff switch to check if the fault is repaired. Check if the light bulb turns on properly, or if the voltage at the part that was repaired can be measured properly. If the repair is complete, clean up the used equipment. Especially, make sure that the lead wire of the equipment, such as a multimeter, is not disconnected.
주로 저희가 이제 실무에서 보면은 고장이 나는 게 사실은 그 부품 손상이나 아니면은 단선, 뭐 선 빠짐, 주로 이제 그런 고장이 많죠. 그래서 실질적으로 우리가 이제 대회에서는 뭐 선을 바꾼다든가 그 다음에 뭐 쇼트를 쇼트까지는 모르겠지만 어쨌든 단선, 그 다음에 부품 손상, 뭐 휴즈 단선, 뭐 이런 걸 많이 하는데 실질적으로 제가 이제 실무에서 볼 때는 주로 이제 부품 손상이라는 게 뭐 릴레이, 코일이 소손된다든가, 마그네트 스위치 코일이 소손된다든가, 뭐 이런 정도겠죠. 그 다음에 단선, 뭐 이런 게 주로 고장의 원인이 되는 것 같습니다.
In the real working place or our daily life, the most popular fault in the air conditioning unit is such as the damage on the component or the disconnection of the wire. But in the competition, we can intentionally make some faults such as the disconnection or the damage on the component or the disconnection of the fuse. But in the real situations, you can see the most popular fault is the component damage on the component, such as the relay coil on the magnet switch or the disconnections of the wire.
작업자가 이제 하는 것처럼 여러분들이 찾으시면 되는데 사실은 우리가 선이 바뀐다든지 나머지 부분들은 우리가 연속성 검사에서 다 이제 찾아지게 됩니다. 처음에 뭐 N상, 그다음에 L상, 접지 연속성 검사일 때, 그다음에 누전 검사, 절연 검사할 때 대부분 고장 수리가 제 생각에는 다 찾아지는 것 같고, 이 단선 부분은 이제 좀 찾기가 어려울 수도 있죠.
So in case of the fault such as the wrong connection of the wire, the most of competitor can figure out that fault by checking the N line or the L lines through the continuity test or the insulation test in the first place. But in case of the fault such as the disconnection of the wire, can be a little bit hard to figure it out.
그래서 이제 요 화면을 잠깐 보여주시면은 제가 도면을 하나 뭐 아주 간단한 도면을 하나 그릴게요. 우리 전원 코드가 이렇게 있고.
Please have a look at the screen, and then I'm going to
잘
draw
안
the
되네요.
simple
네.
diagram on the screen.
그냥 이렇게 그리겠습니다. 램프가 하나가 이렇게 있고.
There is a lamp on the diagram connected with the wire.
여기 뭐 220볼트가 이제 투입이 되고 0볼트가 투입이 된다고 봤을 때
And to each line, the 220 voltage and the 0 voltage is applied to the each lines.
램프에 이제 불이 점등이 될 거고요.
And then you can see the lamp is on.
만약에 램프에 불이 안 들어올 경우는 우리가 이쪽 두 램프 양쪽의 전압을 이제 체크를 해야 되겠죠. 이 양쪽 전압을 체크해서.
In case that the lamp is not on, you can check the both side of the wires for checking.
220볼트가 테스터기로 점검했을 때 220볼트가 들어오는지.
So for checking the actual voltage is applied or not.
램프가 만약에 불이 들어왔을 때는 당연히 이제 220볼트가 이렇게 들어올 거고.
If the lamp is on, definitely the 220 voltage is applied to the system.
그 램프에 불이 들어오지 않았을 때가 이제 문제인데, 램프에 불이 들어오지 않았을 때 우리가 테스트하기로 점검했을 때 220볼트가 들어온다면은 램프 불량이고, 만약에 220볼트가 들어오지 않는다면은 어디 라인이 이제 커팅이 됐다는 거겠죠.
So when the lamp is not on, but the tester shows the 220 voltage on the display, it means that the lamp is the faulty one. But in case of that, the lamp is not on, but the tester still shows the 220 voltage, it can be some problem on the wires connections.
저희가 이제 어떤 램프에 불이 안 들어왔을 때는 실제로 전압이 220하고 0볼트가 투입이 되는지 확인하시고.
So in case that the competitor sees the lamp is not on, check if the 220 voltage is applied to the unit or not first.
전압이 투입이 되고 있으면은 그 테스터기로 램프 양단의 전압을 재고요.
After checking the 220 voltage is applied to the system, then check the both side of wires with the tester.
220볼트가 가해지면 220볼트가 가해지면은 램프 불량이고.
If you can see the 220 voltage on the display of the tester, the lamp is the faulty one.
220볼트가 가해지지 않으면은 라인에 어떤 문제가 있는 거겠죠.
And then, but in case that you cannot see the 220 voltage on the display of the tester, it must be problem in the connection of the wires.
이때는 아마 이 부분이 이제 우리가 단선이 됐다고 가정을 하면은,
For example, if there is the disconnection of the wire on the part of what I just marked now,
이 부분이 요 양단 전압이 220볼트가 나올 겁니다. 테스트하기에서.
the both side of the part of what I just pointed can show the 220 voltage.
여러분들이 원하는 게 있고, 그 원하는 그 램프가 불이 안 들었을 때 전압이 나오면서 램프가 안 들어올 때는 그쪽이 문제고, 단선이 된지 안 된지는 그렇게 확인하시면 되겠습니다. 어쨌든 문제가 있는 쪽에서 220이 나온다. 요건 이제 단선일 때 문제가 되겠습니다.
So the explanation is about the case that there is some disconnection of the wire. So if the competitor can see the lamp is not on, you can see if the 220 voltage is applied to it or not properly, and then you can find out the disconnection part according to it.
요 전에 보셨던 동영상 같은 그런 좀 시뮬레이터를 좀 만들으셔서 좀 초보자 훈련을 좀 많이 하시고 다음 파트에서 하는 실제 에어컨을 가지고 하는 훈련을 하시면은 어느 정도 많이 성장이 될 걸로 보입니다.
For the beginner training, we just recommend to use the simulator, what it just showed on the video clip in the first of all. But after that, and then if the practice is done for a few times, now they can use the actual air conditioning unit for the training.
네, 다시 또 계속 보겠습니다.
Now let us watch the video clip continuously.
Examining the electrical installation on an actual air conditioning unit. For workers' safety, attach safety signs to circuit breaker, power outlet, and other equipment to prevent outsiders from operating them randomly. To check the diagram and the wiring of the air conditioning unit, disassemble some covers of outdoor and indoor unit. Using a digital multimeter, conduct the continuity test on the terminal L and M. Ground continuity inspection, earth insulation inspection, and interline insulation between L and N phases are conducted sequentially. If the resistance value between the two terminals is abnormal, it can cause fire due to the damage of circuit breaker trip and electrical components breakage or sparks. Therefore, check for any problems before supplying power. The actual air conditioning unit is consisted of outdoor and indoor unit, so there is also a communication wire that connects between the two. Be sure to inspect not only the main wire of the machine, but also the communication wire. The refrigeration unit usually consists of several basic control circuits that are operated by their own sequence, which operates following the whole sequence again. What is a sequential control? It is a control system which proceeds step by step according to a set sequence. If power is supplied with a switch, it operates the load according to the conditions of the auxiliary relay in the circuit or the switch. If the circuit test is completed, put the covers on the machine again and supply power. Control systems for refrigeration systems and air conditioners are divided into main and auxiliary circuits. If you conduct the design and the wiring by distinguishing each circuit part and control part, they can easily find the fault when the control system of the refrigeration unit has any problem and accurately conduct the repair by exchanging proper components. The actual wiring diagram might use a different operation method and components depending on the designer's intention and purpose. So, be sure to understand the control system by checking the wiring diagram provided by the manufacturer. Before supplying power, make sure to conduct the power voltage test so that the accurate voltage can be provided. Connect the power to the air conditioning unit and operate it to check if it works without any problems.
네, 비디오 잘 보셨나요? 네. 요것으로 이제 전기 고장 찾기하고 이제 수리 과정은 이제 설명을 드렸고요. 항상 어려운 것 같습니다. 가장 훈련하는 것 중에서 여러분들은 어떠신가요? 저희는 고장 수리가 가장 좀 어려운 것 같습니다. 그래서 이게 선수들이 또 학생들이 이 고장을 찾기 위해서는 전기적인 것도 다 이해를 해야 되고 이 다음 파트인 기계적인 부분도 그 냉동 사이클이라든가 어떤 냉동기 특성 이런 걸 모든 걸 다 선수들이 이해했을 때 이 고장 수리를 원만하게 찾는 것 같습니다.
So now we'd like to finalize the video clip about the fault finding and the repair the fault in the electrical fault part. And I think it is the most difficult part for the training. What do you think about it? And then for the competitor to figure out or find the fault in the air conditioning system, it should be based on the overall understanding on the electrical part and the mechanical feature of the air conditioning system. After that, the competitor can figure out what is the fault in the system.
네, 이제 전기 이걸로 마치고요. 기계 고장 수리하는 파트 동영상으로 넘기겠습니다.
So now let us move to the next step about the mechanical fault finding and repair the fault.
그리고 잠깐 제가 이제 동영상을 정지하고
Let me just stop
네.
the video clip over here.
시작하자마자 끊어서 죄송하고요. 그 이번에 이제 기계 고장 수리는 저희가 이제 좀 여러 가지 상황이 있겠지만은 좀 나눠봤습니다. 이제 우리가 그 고장을 보면은 이제 고압이 높은 경우하고 이제 저압이 낮은 경우로 이제 구분을 해서 뭐 그 외에도 많은 고장 부분이 있겠지만 크게 나누면 이제 그 두 가지 고압이 낮은 거하고 고압이 높은 거하고 저압이 낮은 거.
So now it is about the mechanical fault finding and repairing the mechanical fault. So I think there are many types of mechanical fault in the real situations, but I would like to divide the mechanical fault into two types, such as the high pressure part and the low pressure part. For example, when the high pressure is increased and the low pressure is decreased.
지금 고압이 높은 이유를 이제 저희가 이제 세 가지 종류로 통상적으로 이제 실무에서 많이 일어나는 일이 이제 응축기 풍량 감소 첫 번째가 그다음에 냉매 과충전 그다음에 불응축 가스 이렇게 세 파트로 나눠서 저희가 지금 동영상을 촬영했습니다.
So firstly, it is about when the high pressure is increased. So there are three main causes for this situations. The first is the decrease in the air volume of the condenser, and the second cause is that the overcharging of the refrigerant, and lastly it is the fault.
non-condensed gas.
It is the fault of the mixed in the non-condensable gas.
네, 그 세 가지를 저희가 이제 고장별로 이렇게 선수한테 지도하고 학생들한테 지도하는 게 그 좀 쉽지가 않아서 일단 저희는 훈련을 이렇게 하고 있습니다. 그 정상적인 그 장비를 가지고 그 어떤 온도, 압력, 그다음에 운전 전류 이 모든 거를 이제 풍량 모든 걸 다 측정한 다음에 그 정상적인 값을 한 번 측정하는 게 아니라 최소한 2번 이상 측정해서 고장이 났을 때 그 정상적인 값과 이제 비교를 하는 거죠. 어떤 변화가 있는지. 예를 들면 운전 전류는 어떻게 변화가 있는지, 압력은 어떻게 변화가 있는지, 고압이 같이 높은데 어느 때는 관행 각도가 어떤지, 과열도가 어떤지, 운전 전류가 어떤지. 그래서 그런 거를 선수 스스로, 학생 스스로 느낄 수 있게끔 하는 게 우리 동영상의 목적이라고 보시면 되겠습니다.
When I train the competitor or the student, I just recommend for the competitor or the student to take a measurement of the normal operating conditions, such as by taking a measurement of the temperature, pressure, the operations current, or the air volumes. So I just recommend for them to take a measurement of damp at least 2 times. So after that, I just make them to compare the difference or the changes between two data. So when there is when the high pressure is increased, I just recommend for them to check if there is any change in the superheat or the subcooling or the operating current.
네, 그래서 이제 저희가 이제 고민을 하는 게 이게 만약에 저희 프로그램을 쫓아서 이렇게 따라서 하시면서 이제 가장 중요한 포인트가 무엇이냐면요. 이게 한 번, 두 번 해가지고 이거를 데이터를 내는 거는 부정확할 확률이 높고 많은 여러 번의 그 실험을 거쳐 가지고 평균값을 가지고 했을 때 좀 정확도가 높아지는 것 같습니다.
So, regarding to follow the training program, you guys are making sure to try to take a measurement several times, and then you guys try to figure out the difference or the change by comparing several times of a measurement, and by checking the average value of each data or the change.
예를 들면은 그 정상적인 그 장비에 우리가 센서를 부착할 때도 같은 위치. 예를 들어서 고압 측의 그 은축기 콘덴싱 그 출구 쪽 배관 온도를 잴 때도 정상적인 제품과 또 고장이 났을 때 같은 위치에 센서를 부착하는 게 중요하고요.
So, for example, it's really important to install the temperature sensor exactly on the same position or the locations before the fault or after the fault. For example, if the competitor installed the temperature sensor on the side of the outlet of the condenser in the high pressure side, they need to make sure to install the temperature sensor on the exact positions even after making the fault.
그다음에 이제 선수들이 이제 귀찮으니까 이제 자기들이 이제 탈거해 놓은 그 커버 같은 경우를 닫지 않고 하면은 이제 선수한테도 학생한테도 작업자에게도 위험하겠지만은 또 이게 공기 유량이 달라지기 때문에 정확한 측정이 안 됩니다. 그래서 반드시 커버는 완전 조립은 아니더라도 가조립 상태로 해놓고 하는 게 중요합니다.
So in case that the sometimes competitor try to conduct the fault finding task or repairment task while just leaving all the units is disassembled, but it is very dangerous, and then it can cause some change in the flow rate of the air. So the competitor makes sure to reassemble the disassembled units temporarily while they conducting the task.
두 번째 중요한 거는 예를 들어서 응축기 풍량을 감소하면 우리가 종이를 좀 가려서 응축기 일부분을 가려서 풍량 감소를 일으키고 불응축 가스도 질소를 넣어가지고 불응축가스를 유발시키고 그다음에 냉매를 과충전할 때도 일정한 냉매를 과충전해야 되는데 이게 다 일정해야 된다는 거죠. 할 때마다 일정해야지 어떨 때는 종이를 2장 대고 어떨 때는 냉매를 한 번은 400g 넣고 한 번은 600g 넣고 이러면은 데이터 값이 차이가 있어가지고 정확한 우리의 데이터 값을 내기가 어려우니까 항상 정량 똑같은 방법으로 훈련하는 게 좋겠습니다.
So when causing the air volume of the condenser get decreased, they need to make sure to put or insert the paper in front of the condenser fan, and in case of that, making some mixed in the non-condensable gas into the system, they need to inject or apply some nitrogen gas to the system. And lastly, if they would like to make the fault, such as the overcharging of the refrigerant, they can add extra amount of the refrigerant to the system. But when they conduct causing the fault, such as what I mentioned. They need to make sure to follow exactly the same procedure, so it just can prevent all the data or the change get different in every trial.
네, 그러면 다시 이제 동영상으로 돌아가서 네, 우리 통영이 너무 고생하시는 것 같아서 네, 이제 동영상을 다시 감상하시겠습니다.
Let us watch the video clip again.
통영 고생한다는 얘기 왜 안 하죠?
자기 자랑 같아.
Main focus of the task in this training is as follow. First, to reduce errors in data, examine the problem with several trials instead of finishing it with a single trial. Second, testing instruments such as digital thermometer must measure the same points during both normal operation and fault finding. Third, when measuring wind speed, it is necessary to measure the wind volume at several places as much as possible, rather than only one place, and to make an average value. Fourth, when installing a manifold gauge, install it where the refrigerant in the hose can be reclaimed. Fifth, after the repair is completed, competitors should always check if the machine operates properly. Sixth, to figure out the reason for the fault, it is necessary to train workers by comparing the normal refrigeration cycle and the refrigeration cycle which has a mechanical fault. Please check the preparations and tools for this training. These are precautions. First, before repairing the fault, competitors should attach a danger sign at the end of the power cord. Second, since this work deals with the refrigerant, make sure to wear a safety gear to prevent low temperature burns. Third, the sensor for temperature measurement should be attached to the exact position. Fourth, before using measuring equipment such as a thermometer and a manifold gauge, make sure to adjust it to 0. Fifth, when supplying power, make sure to wear insulated gloves. Sixth, before and after supplying power, make sure to conduct the electrical short test and insulation test. Seventh, the likely cause of failure is high pressure, so be careful of changes in high pressure. Eighth, operating faulty equipment for a long time to find the fault can lead to the additional damage to the machine. Ninth, care must be taken in insulating the sensor parts so that the temperature measurement data values are not affected by external factors.
네, 지금 잘 보셨나요? 조금 지금까지는 이제 주의사항 제가 방금 전에 설명드렸던 내용을 좀 요약적으로 지금 보여준 것 같습니다.
The video clip what I just show you is about the key points what the competitor should care about when conducting the task. So it is summarized my explanations.
예, 지금 이제 나머지는 이제 좀 주의사항 있고 해서 그건 건너뛰고 이제 정상 운전을 이제 체크하는 방법, 이 두 번에 걸쳐서 평균값을 내기 위해서 이제 정상 상태의 그 운전 상태를 점검하는 내용이 되겠습니다.
So now we are going to watch about the parts, how to take a measurement of the normal operating conditions by taking a measurement at least 2 times for making the average value in between them.
Examining the normal operating condition. Write data of the equipment in normal condition. Measure and write down the compressor operating current, the air velocity of indoor and outdoor unit, the high and low operating pressure, the superheat, and the subcooling. When measuring the air velocity of indoor or outdoor unit, divide the inlet or outlet of indoor or outdoor unit into 4 to 6 sections and measure the air velocity in each divided sections to get an averaged value. If you multiply the average value with the area of indoor unit, you can get the average air velocity of the machine. The situation of the fault regarding to the decreased air volume in condenser. Put a paper over the outdoor unit to intentionally decrease the air volume of condenser. Check how the data gets changed compared to the data from the normal machine. There can be several reasons for the decreased air volume of the outdoor unit, but it commonly experiences an abnormal increase in the discharge pressure, which is a high pressure part. Reasons for the decreased air volume of the outdoor unit. When the motor does not rotate properly because of the functional problem in motor. When the wing of the fan is damaged. When the pins on the suction side of the outdoor unit are clogged with foreign substances. When the outdoor unit is placed in a problematic location. Measure the compressor operating current. High pressure rises due to a lack of heat exchange, causing the compressor operating current to rise as well. If the place where the condenser is installed is not ventilated and has a lot of dust, the contaminants will stick to the refrigerant pipe and cooling fin. In this case, the heat does not exchange, rising the high pressure. If a leaf or a paper is stuck to the condenser, the heat does not exchange as well. As a result, condensation will not take place well, but the pressure at the high pressure part will increase. Let's compare the data of when the air volume of condenser is decreased with when the condenser is operating normally. Check for any noticeable changes. Increase in discharge pressure. Increase in compressor operating current. Decrease in air volume of condenser. No change in the degree of supercooling of the condenser. No change in the degree of superheat of the evaporator. The reason for the data change is because the heat exchange is not taking place properly at the condenser. The condensing medium of an air-cooled condenser is the air that exchanges heat. If the air volume is not adequate, the condensing efficiency decreases and the discharge pressure increases. If the condenser is placed close to a wall or any other obstacle, the hot air discharged after the heat exchange gets sucked in again, making the heat exchange ineffective. When there occurs symptoms such as the increase in discharge pressure, the increase in operating current, and the decrease in the air volume of condenser, the contamination in the condenser or the faulty condensation are assumed as the reason for the fault. In this case, there is no change in the degree of supercooling of the condenser and the degree of superheat of the evaporator. The situation of the fault regarding to the refrigerant overcharging. Overcharging the refrigeration system with refrigerant intentionally makes the machine in a dysfunctional state. The overcharged amount of refrigerant is 600 grams. Check how the data gets changed compared to the data from the normal machine. Measure the discharge pressure and the suction pressure during operation. If the refrigerant is overcharged in a refrigeration cycle, the discharge pressure gets abnormally high. Measure the temperature of the condenser outlet. Although the temperature dropped only a little bit, the degree of supercooling changes considerably due to the change in discharge pressure. Measure the compressor operating current. the operating current is higher than normal. Let's compare the data of when refrigerant is overcharged with when the machine operates normally. Check for any noticeable changes. Refrigerant is overcharged 600 grams more than the normal amount. Increase in discharge pressure. Increase in the degree of supercooling of condenser. Decrease in superheat of evaporator. Increase in compressor operating current. Normal air volume of the condenser. It is because of the excessive amount of liquid refrigerant that had accumulated on the condenser, decreasing the capacity of the condenser. It is because the part of the condenser where the liquid refrigerant is filled cannot work properly as a condenser. Therefore, when the subcooling increases excessively, the liquid refrigerant which was unable to be evaporated keeps flowing into the compressor. When there occurs symptoms such as the increase in discharge pressure, the increase in subcooling of condenser, the decrease in superheat of evaporator, and the increase in compressor operating current, the refrigerant overcharging is assumed as the cause of the fault. In this case, there is no change in the air volume of the condenser. The situation of the fault regarding to the mixed-in non-condensable gas. Inject some nitrogen gas into the refrigeration system intentionally to make it in a dysfunctional state. When non-condensable gases such as air are collected in the condenser during piping, the condensation volume of the condenser is reduced due to the non-condensable gases, which results in higher discharge pressure than the pressure corresponding to the condensation temperature of the refrigerant vapor. Check how the data gets changed compared to the data from the normal machine. While the machine is operating, measure the discharge pressure, the temperature of condenser outlet, the suction pressure, the temperature of evaporator outlet, the compressor operating current, and the air volume of both compressor and evaporator using a manifold gauge. Why non-condensable gas can cause some problem. It is because non-condensable gas gathers at the upper part of condenser and interferes with the condensation of the refrigerant. If the amount of non-condensable gas increases, the heat exchanging area decreases, hindering the heat exchange efficiency and the condenser's performance. Therefore, it can be the cause of decreasing the refrigerating ability since it increases the condensing pressure, increasing the shaft power of compressor as well. However, there is no obstruction at the part where the wind goes out, so there is no change in air volume at the compressor or evaporator. Let's compare the data of when some non-condensable gas is mixed in with when the machine is operating normally. Check for any noticeable changes. Increase in discharge pressure actually. Increase in subcooling of condenser. Suction pressure hunting phenomenon. Increase in superheat of evaporator. Increase in compressor operating current. No change in the air volume of the condenser. To prevent some non-condensable gases from being mixed in, seal the refrigerant piping system properly and make sure there is no remaining air or non-condensable gases by sufficiently conducting the evacuation procedure. When the refrigerant being charged, be careful so that no air or moisture is mixed in. When there occurs the symptoms such as the increase in discharge pressure, the increasing in subcooling of condenser, the suction pressure hunting phenomenon, the increase in superheat of evaporator, and the increase in compressor operating current, the mixed-in non-condensable gas is assumed as a result for the fault. In this case, there is no change in the air volume of the condenser. After completing the task, the tools and measuring gauges used for examining and repairing the fault should be removed. All sorts of covers or caps that were disassembled, such as a pressure controller and joint box, should be reassembled to the original state. We have reviewed 3 reasons the cycle of the refrigeration unit is operated with high discharge pressure. There are three main reasons why the cycle of the refrigeration unit is operated with high discharge pressure. Decreased air volume of condenser, refrigerant overcharging, mixed-in non-condensable gas. These read differences in the measured data depending on three reasons above. If the condenser air volume decrease is the cause, it shows the problems such as increase in discharge pressure, increase in compressor operating current, and decrease in air volume of condenser. No change in the degree of supercooling of the condenser. No change in the degree of superheat of the evaporator. When the refrigerant is overcharged, increase in discharge pressure, increase in subcooling of condenser, decrease in superheat of evaporator, increase in compressor operating current. But the air volume of condenser is normal. When some non-condensable gas is mixed in, increase in discharge pressure, increase in subcooling of condenser, suction pressure hunting phenomenon, increase in superheat of evaporator, increase in compressor operating current, no change in the air volume of the condenser. Even if the discharge pressure is high, there can be a difference in the specific data depending on the situation. In order to quickly find the fault and its reason, it is necessary to understand the problems that occur according to situations and to be trained repeatedly by comparing the difference in the measured data.
네, 표를 보고 다시 조금 더 설명을 드릴게요.
After checking the data sheet on the video screen, so I'm going to give you the additional explanation on it.
표에서 보시는 것처럼 제일 처음에 이제 저희가 정상적인 이제 표가 있고요. 정상적인 걸 이제 두 번에 걸쳐서 하게 되겠고요.
The first part of the data sheet is about the normal operating conditions. So it is going to be measured 2 times.
이 순서대로 하시는 거를 권장드립니다.
I recommend to follow the procedure from the left section to the right section.
예, 뭐 이제 고잡을 분간하기 이전에 이제 훈련할 때는 이 순서대로 하시는 거를 권장드립니다.
Before dividing the faults depending on the high pressure change or the low pressure change, I just would like to recommend to follow the procedure from the left to the right.
그 이유는 뭐 이런 두 파트는 이제 에바포레이터하고 콘덴서 그 풍량 부족하는 거는 종이만 이제 붙였다 뗐다 하면 돼요. 간단한 거고.
The first 2 section is about the evaporator and the condenser part. So it is quite easy to cause the fault by just adding some paper.
맨 마지막에 그 배관 찍힘은 한번 배관을 찝으면 다음 우리가 테스트를 할 수가 없으니까 맨 마지막에 항상 훈련의 맨 마지막에 배관을 찝는 테스트 시트를 작성하는 게 좋을 것 같습니다.
In the last section, there is a fault by being made by pinching the pipe for causing the dented pipe. So after pinching the pipe to make the dented pipe, it is not available to proceed the other fault finding task after that. So
브롱슈 가스도 그 배관 찍힘 전에 하시는 게 좋을 것 같고요.
So I recommended to proceed the training about the mixed in non-condensable gas fault should be done before the dented pipe fault part.
좌측에 있는 12가지 항목은 우리가 가장 기본적인 항목입니다.
So you can see the 12 items on the left side of the data sheet, and it is very basic items.
네, 뭐 처음에 이제 뭐 냉매 종류가 뭔지부터 시작해서
So firstly, it is about the type of the refrigerant.
그다음에 뭐 디스차지, 프레셔, 그다음에 뭐 쭉 뭐 순서가 일반적으로 우리가 많이 하는 그런 석션 프레셔, 그다음에 끝으로 가서는 에어 볼륨 그런 종류니까 그 내용도 한번 확인하시고 나름대로 만드셔서 이 표를 만드셔서 저희께 꼭 뭐 스탠다드고 정답은 아니니까 여러분들이 추가하실 건 추가하시고 항목을 좀 빼실 건 빼셔서 훈련에 임하시면 될 것 같습니다.
So from the top to the bottom, it all about the discharge pressure, suction pressure, and air volume, etc. So please check all the contents of the items, what I just marked on the data sheet, and then please add some items or delete some items if you need to make or design the unique individual data sheet for the training.
네, 그러면 이제 고압은 요걸로 마치고 이제 저압으로 넘어가겠습니다.
Let us finalize the fault finding parts of the high pressure part.
저압 쪽도 고압하고 중복되는 부분이 초반에 많기 때문에 중간 초반에 이제 어떻게 하는 요령, 뭐 주의사항 이런 게 계속 중복이 되기 때문에 중간에는 저압 부분으로 바로 넘어가겠습니다.
So now it is about the fault finding task of the low pressure part, but there are a lot of repeated content or the same content what you just see in the previous video clip. So I'm going to skip a few parts.
저압은 이제 고압과 비슷합니다. 고압과 비슷하고 풍량 감소가 있고요. 그다음에 냉매 부족. 고압에서는 냉매를 과충전했고 여기서 냉매 부족이고요. 그다음에 배관이 어디 막힘, 예를 들어 스테나라든가 배관이 씹혔다든가 팽창변이 막혔다든가 이런 배관의 어떤 막힘 고장에 대해서 저압은 저희가 이제 체크 시트를 만들고 증상을 만들어서 훈련을 하는 게 되겠습니다.
So the fault when the low pressure part gets decreased, there are few faults. So such as the decrease in the air volume of the evaporator, and there is also the lack of the refrigerant, unlikely the high pressure parts what I just mentioned in the previous video clip. And lastly, there is the fault about the dented pipe. So it means that the clogging or the blockage in the pipe.
네, 그러면 동영상 함께 보시겠습니다.
Let us watch the video clip about this now.
This is a malfunction of the evaporator air volume reduction. Intentionally create the malfunction state in which the air volume of evaporator is decreased by adding the paper over the indoor unit. Check how the data gets changed compared to the data from the normal machine. Measure and write down the compressor operating current, the air velocity of indoor and outdoor unit, the temperature of evaporator outlet, the temperature of condenser outlet, the high and low operating pressure, the superheat, and the subcooling. If the air volume through the evaporator is abnormally insufficient, the refrigerant flowing in the coil will not evaporate properly. The refrigeration capacity is lower than when the refrigerant evaporates normally, and the refrigerant that is not evaporated is inhaled to the compressor side, which causes failure. There are many reasons that reduces the air volume of evaporator. First, there is a case where the air filter or evaporator on the suction side of the indoor unit has foreign substances or dust, decreasing the air volume. In addition, there is a case where the evaporator is not operating in normal RPM because of the broken motor. There is a case where the wing of fan is broken. And there is a case where objects interfere with the airflow in the inlet and outlet of the indoor unit. Therefore, when the evaporator is experiencing the decreased air volume, make sure to measure the air volume. Let's compare the data of when the evaporator is experiencing the decreased air volume with when the machine is operating normally. Let's check for any noticeable changes. Decrease in suction pressure. Decrease in superheat of evaporator. Decrease in air volume of evaporator. Decrease in subcooling of condensers. Decrease in operating current. The reason for the data change is because the heat exchange is not taking place properly at the indoor unit. Therefore, make sure to conduct overhauls and maintenance on the machine thoroughly to prevent the blockage in air filter and the contamination in refrigerant pipe and cooling fin of the evaporator, and to make evaporator fans operate properly. When there occur the symptoms such as the decrease in suction pressure, the decrease in superheat of evaporator, and the decrease in air volume of evaporator, the faulty heat exchange of the evaporator is assumed to be the reason for the fault. This is a malfunction due to insufficient refrigerant. Reclaim the refrigerant from the refrigeration system intentionally to make it in a dysfunctional state. The reclaimed amount of refrigerant is 200 grams out of the fixed amount of 1,000 grams. Check how the data gets changed compared to the data from the normal operation. Measure the compressor operating current, the temperature of evaporator outlet, the temperature of condenser outlet, the high and low operating pressure. Insufficient refrigerant may result in a decrease in both suction and discharge pressure. In addition, the increasing superheating degree of the system causes compressor failure due to overheating and deterioration of the freezing capacity. Measure and record the air velocity of the indoor and outdoor units. When measuring air velocity, the air inlet or outlet of the indoor and outdoor units shall be divided into 4 to 6 equal parts to measure the air velocity of each zone and obtain the average value. Let's compare the actual value of when there is a lack of refrigerant with when the machine operates normally. Check for any noticeable changes. The reclaimed amount of refrigerant is 200 grams. Decrease in discharge pressure. Decrease in subcooling of condenser. Decrease in suction pressure. Increase in superheat of evaporator. Decrease in compressor operating current. When there is a lack of refrigerant of refrigeration equipment as well as measured data. If a sight glass is installed, bubbles are visible in the liquid refrigerant. Therefore, when there occurs the symptoms such as the decrease in discharge pressure, the decrease in subcooling of condenser, the decrease in suction pressure, the increase in superheat of evaporator, and the decrease in compressor operating current, the lack of refrigerant is estimated to be a reason for the fault. This is the situation where the pipe is dented. Distort the pipe of the refrigeration equipment intentionally to make it in an abnormal dysfunctional state where the refrigerant flow is hindered. Check how the data gets changed compared to the data from the normal machine. Measure discharge pressure and suction pressure during operation. If the refrigeration circulation is hindered, only a small portion of the refrigerant goes through the evaporator, resulting in lower suction pressure. Measure the temperature of evaporator outlet and the temperature of condenser outlet. When the filter dryer in the liquid tube is blocked, the outlet temperature is lower than the inlet temperature due to the difference in pressure between the inlet and outlet of the filter dryer. Similar problems occur when the liquid line is blocked or bent. Measure the compressor operating current. If the refrigerant does not flow smoothly, the pressure at the low pressure part gets low. It causes the low pressure controller to operate, which stops the refrigeration equipment. Measure and write down the air velocity of indoor and outdoor unit. When measuring the air velocity, divide the air conditioning unit into 4 to 6 sections to measure each section and calculate the average value. Let's compare the data of when the pipe is dented with when the machine operates normally. Check for any noticeable changes. Little decrease in discharge pressure. Little increase in subcooling of condenser. Decrease in suction pressure. Increase in superheat of evaporator. The reason for the data change is because the refrigerant circulation is hindered. Only a small portion of the refrigerant circulates, resulting in lower suction pressure. The superheating changes as the evaporation process becomes shorter and the suction pressure decreases. Therefore, when there occur the problems such as little decrease in discharge pressure, little increase in subcooling of condenser, the decrease in suction pressure, and the increase in superheat of evaporator, the dented pipe is estimated to be a reason for the fault. After completing the task, the tools and measuring gauges used for examining and repairing the fault should be removed. all sorts of covers or caps that were disassembled, such as a pressure controller and joint box, should be reassembled to the original state. We have reviewed 3 causes of failure operated under low suction pressure up to now. The reasons why the suction pressure in refrigeration unit gets lower comes from the failures of piping such as decreased air volume in evaporator, a lack of refrigerant, the dented pipe. In addition, there may be several causes such as valve lock, expansion valve lock, or failure. These are differences in the measured data depending on 3 reasons above. When the decrease in air volume of condenser is the reason, the symptoms such as decrease in suction pressure, decrease in superheat of evaporator, and decrease in air volume of evaporator may appear. When the lack of refrigerant is the cause, the symptoms such as decrease in discharge pressure and increase in discharge gas temperature, decrease in subcooling of condenser, decrease in suction pressure, increase in superheat of evaporator, and decrease in compressor operating current may appear. When the defective piping system, such as a dented pipe, is the cause, the symptoms such as little decrease in discharge pressure and little increase in subcooling due to the changes in the condenser pressure, decrease in suction pressure, and increase in superheat of evaporator may appear. Even if the suction pressure is low, there can be a difference in the specific data depending on the situation. In order to quickly find the fault and its reason, it is necessary to understand the problems that occur according to situations and to be trained repeatedly by comparing the difference in the measured data.
네, 동영상 잘 보셨나요? 좀 주의사항이 좀 있는데요. 그 냉매를 예를 들어서 조금 뺀다든가 저압을 낮추기 위해서, 아니면은 냉매를 좀 많이 넣는다든가, 아니면 풍량을 줄이기 위해서 종이를 덧댄다든가 할 때는 너무 작게, 냉매를 작게 뺀다든가 너무 작게 넣으면은 그 변화를 우리가 알 수가 없거든요. 또 반대로 너무 또 과하게 넣고 과하게 빼면은 장비의 문제라든가 위험성이 또 있습니다. 그래서 지금 저희가 지금 보여드리는 동영상을 참고하셔서 이 훈련을 할 때는 반드시 그 학생 또는 선수 혼자서 하는 게 아니라 숙련된 기술자나 지도자가 있는 가운데서 하시기를 권고드립니다.
So there is one more important point I would like to highlight. So for making or causing the fault, the people should add or subtract the refrigerant. But if the competitor or the workers inject or add the too much refrigerant or too small, so there is some problems occurred. So for example, too many refrigerant get charged, it can just cause some malfunction of the overall equipment or the system. In case that too small refrigerant is charged or subtracted, there is no noticeable change be observed. So make sure to conduct this task by causing the fault under the expert or the professional's supervisions.
네, 이제 우리가 이제 고장을 찾았으면 이제 수리를 해야 되겠죠. 그래서 이제 수리를 하기 위해서는 장치 내에 있는 이제 냉매를 빼내고, 배관이 이제 찌그러든 부분은 수리를 하고, 냉매가 과충전됐으면 이제 정량을 넣고, 또 불응축가스도 마찬가지죠. 그래서 이제 저희가 고장난 걸 수리하기 위해서 이제 냉매를 회수해야 되는데, 그 회수 과정을 여러분과 함께 보겠습니다.
So now the competitor find the fault in the air conditioning system. So now they need to repair the fault. So to conduct the repair task, they should reclaim the refrigerant from the entire system. So now we are going to give you the explanation about how to reclaim the refrigerant from the system.
Main focus of the task in this training is as follow. First, before brazing the pipe for the repair, you should be able to reclaim the refrigerant that is charged into the machine. Second, before reclaiming the refrigerant, you should be able to conduct the evacuation procedure on the refrigerant recovery machine. Third, you should be able to understand how to connect the manifold gauge to the machine. Fourth, you should be able to understand how to connect and use the refrigerant recovery machine. Fifth, you should be able to understand the procedure for reclaiming the refrigerant. Sixth, the weight of the reclaimed refrigerant should be measured. Seventh, the leakage test should be conducted in all connecting parts before, during, and after the refrigerant recovery. Eighth, brazing should be mace according to the brazing standards. Ninth, when brazing the pipe, the brazed face should be even, and over 2/3 of the deposited metal should be penetrated into the sufficiently expanded connection part. 10th, the leakage test of the oxygen welder should be conducted before brazing. 11th, when igniting the flame, be careful not to cause any black smoke. 12th, you should be able to know how to control the intensity of the flame with a neutral flame. 13th, when the torch flame is strong, make sure the copper tube is not melted down. Please check the preparations and tools for this training. These are precautions. First, when reclaiming the refrigerant, make sure not to get low temperature burns and refrigerant loss. Second, make sure to always wear a personal safety gear such as safety goggles, long-sleeved clothes, and leather gloves. Third, when using a brazing torch, be careful not to get burned by the fire. Fourth, when brazing, make sure to conduct the oxygen welder leakage test thoroughly to check if there is any sign of gas leakage. Fifth, when brazing, make sure the replacement component and the surrounding components are not damaged by the heat or fire. Sixth, after using the brazing torch, make sure to close the gas valve and discharge the remaining gas inside the hose. Seventh, make sure not to get burnt by the heated copper tube after brazing it. Eighth, conduct the leakage test on the replacement component by pressurizing nitrogen to check if there is any sign of leakage. Ninth, make sure to install the replacement component in the right direction.
네, 지금까지는 저희가 이제 고장 수리를 하기 위한 냉매 해수 작업에서 이제 중요한 사항과 또 주의 사항을 좀 여러분과 함께 봤습니다.
So far we just checked the key points or some precautions points what we need to care about when conducting the repairment, the fault task.
네, 지금부터는 이제 실질적으로 냉매 해소하는 방법에 대해서 동영상을 같이 보시고 제가 중간중간 필요한 부분을 설명을 드리는 시간을 갖겠습니다.
Now let us move to the next step about how to reclaim the refrigerant from the system in actual.
네, 함께 보시겠습니다.
This is to measure the amount of refrigerant recovered. After completing the measurement, put down the recovery cylinder and put away the refrigerant scale. Before reclaiming the refrigerant from the refrigeration system, evacuate the refrigerant recovery machine, recovery cylinder, and the manifold gauge hose. The reason for evacuation work is to remove the non-condensing gas and moisture inside the recovery machine and the recovery container. Open all valves of manifold gauge connected to the refrigerant recovery machine and the recovery cylinder. Then, operate the vacuum pump which is connected to the cylinder. It is possible to evacuate each equipment separately, but evacuating all at once reduces time. After completing evacuation in accordance with the operating standards presented to the operator, close the valve of the recovery container connected to the vacuum pump. Then, stop and remove the vacuum pump. If the refrigerant recovery machine and the recovery cylinder are evacuated separately, connect the low-pressure hose of the manifold gauge to the evacuated refrigerant recovery container and the refrigerant recovery machine sequentially. When the connection is completed, the non-condensing gas inside the manifold gauge hose should be purged before full refrigerant recovery. Prepare refrigerant recovery by opening the high and low pressure valves of the refrigerator. If the refrigerant is overcharged, the discharging pressure increases abnormally, causing overcurrent relay or high pressure controller to be operated and stop the refrigeration system. When the refrigerant is charged, make sure not to overcharge it to prevent this. If it has already been overcharged like this time, reclaim all refrigerant inside the refrigeration system and charge it with the adequate amount of new refrigerant. Since the refrigerant is defined as an environmental pollutant, make sure to be especially attentive when dealing with the refrigerant. Set the inlet switch to open and liquid according to the circumstances and retrieve refrigerant in the unit. The purge switch must be placed in the recover state and the outlet valve must be set to open to recover the refrigerant in the unit. To recover the liquid refrigerant, first place the switch on the inlet side of the recovery device panel on the liquid and open the high-pressure valve of the manifold gauge to recover the liquid refrigerant. What is a push-pull method of refrigerant recovery? The recovery machine inhales gas refrigerant from the recovery container to make high-pressure discharge gas, and the high-pressure gas pushes the liquid refrigerant from the refrigerator to the recovery container. So, it quickly and safely recovers the liquid refrigerant from the large refrigerator. It also helps prevent the freezing of water-cooled refrigerators. When the liquid refrigerant is recovered, change the switch on the inlet of the recovery panel from liquid to open. The manifold gauge low-pressure side valve is also open to simultaneously recover the high and low-pressure refrigerant of the refrigerator. The reason why to reclaim the gas refrigerant after the liquid refrigerant is claimed is because it is the most effective and quickest way. The process for reclaiming the refrigerant only in vapor state takes a long time. During the process of recovering refrigerant, check whether there is any gas leakage into the atmosphere with a gas detector. With a gas detector, you can conveniently detect even the small amount of leakage. If it is placed on a leaking part, the light or the alarm is activated. Check for leakage without leaving out the connection of the refrigerator, manifold gauge, and the connection between the recovery machine and the recovery container. When recovering the liquid refrigerant, it is possible to work while looking at the sight gas. If the liquid refrigerant is no longer visible on the sight glass, the liquid refrigerant recovery is completed, so the remaining gas refrigerant is recovered afterward. After refrigerant recovery is completed, turn off the recovery machine and wait for a moment because the remaining refrigerant in the refrigerator can vaporize and cause the pressure to rise. Wait 2 to 3 minutes to see if the pressure in the refrigerator is rising. When the pressure in the refrigerator rises, operate the recovery machine again to recover all evaporated refrigerants. Repeat this task 2 to 3 times. When the blue low-pressure gauge of the manifold gauge indicates 0, close all manifold gauge valves and stop the operation of the recovery machine. Change the inlet switch on the recovery panel to purge. The low-pressure gauge attached to the recovery machine shows that the value increases from 0. Change the recovery switch of the recovery machine to purge. Purge operation is to send all refrigerant left in the recovery machine to the recovery container. It can be seen that the low gauge level of the recovery machine is falling quickly. After the purge is completed, close the valve of manifold gauge connecting the recovery machine and cylinder. Lock the outlet switch of the recovery machine into close mode and close the main valve of the recovery cylinder as well. Remove the hose of the manifold gauge connected to the refrigerator. Since the purge operation has been completed, even if the hose is removed, the amount of refrigerant released into the atmosphere will be very small. Using a refrigerant scale, measure the weight of the recovery cylinder, which has just reclaimed the refrigerant. If subtracting the weight of the empty cylinder from the measured weight, the total amount of the reclaimed refrigerant can be obtained. Attach a sticker that shows the amount of the reclaimed refrigerant, refrigerant type, and the date. Cap the recovery cylinder and conduct the leakage test with a gas detector.
냉매 회수하는 요령 잘 보셨나요? 지금 보신 화면에서 보신 뭐 메이커를 제가 이렇게 거론하기는 좀 그렇고요. 지금 세계적인 그 기업들이 만들어내는 그 회수기들은 다 앞에 그 패널 그 모양이 다 비슷합니다. 그래서 여러분들이 지금 저희가 보여드린 그 화면을 보시면은 충분히 이제 이해하실 거고, 좀 뭐 영상을 한번 보시고 안 되면 저 여러 번 반복적으로 보셔가지고 숙달될 수 있을 때까지 반복적인 훈련을 하시면 될 것 같습니다.
So how about the procedure about how to reclaim the refrigerant from the system? So as you already know that many global brands, the recovery machine which is manufactured by the many global brand has the similar layout or the shape of the in front panel. So by watching the video clip repeatedly for your training, please, I hope the competitor can get used to the whole procedure what I just show you in the video clip.
저희가 이제 뭐 장장 여러 개월 동안 저희가 그 동영상을 가지고 유튜브 방송을 했는데 마지막 이제 12차 영상을 끝으로 남았네요. 네, 보시면서 오늘 마무리를 하는 시간을 갖도록 하겠습니다.
We spend a lot of time to give you the instruction about the whole things regarding to our skills from the last 3 sessions of the live streaming. But now we only have the last video clip, the number 12. Let us watch the last video clip together.
네, 잠깐 제가 화면을 좀 끊었습니다. 네, 마지막 그 동영상은 그 제목을 제가 말씀 안 드린 것 같아서 12차시는 이제 질소 가압, 그다음에 진공, 그다음에 냉매 주입, 시운전이 되겠습니다.
I just missed to mention the title of the last video clip, so I just stopped the video clip briefly. So the last video clip is going to be about the pressure test, about the nitrogen gas and the vacuum test and the charging of the refrigerant, and lastly the commissioning.
요 12차시는 우리 그 지난번 우리가 이제 제작할 때 그쪽에서도 우리가 질소 가압, 진공, 냉매 주입, 시운전이 있어서 조금 거기하고 좀 중복되는 부분이 좀 많이 있습니다. 그래서 그 중복되는 부분은 좀 빼고 또 그 에어 컨디셔닝에만 있을 수 있는 그런 내용 위주로 여러분들하고 한번 짚어보겠습니다.
So in the previous session, we already dealt with the part about the pressure test with the nitrogen gas, the vacuum test, and the charging of the refrigerant part. So I would like to skip the repeated part in the video clip number 12. I'm only going to deal with the specific parts which can be applied to the air conditioning system.
Main focus of the task in this training is as follows. First, Before conducting the pressure test with nitrogen, make sure to open all valves. Second, all safety and relief valves should be shut off during the pressure test. Third, during the pressure test, nitrogen should be pressurized safely up to the presented standard pressure to the worker. Fourth, before the evacuation, all sorts of service and solenoid valves should be opened. Fifth, it should be verified whether the vacuum pump can be operated below 1,000 microns. Sixth, for the evacuation test, the evacuation level should be below 1,000 microns within the given time for the task. Seventh, if the vacuum pressure does not be below 1,000 microns, make sure to keep conducting the evacuation task until it reaches the desired state. Eighth, the vacuum gauge should be installed as far away from the vacuum pump as possible. Ninth, the manifold gauge must be adjusted to 0 before using it. 10th, in the case of mixed refrigerant, the liquid type must be charged with the liquid service valve or liquid receiver on the high pressure side, as much as the amount of refrigerant to be charged. 11th, when supplementing the refrigerant, it should be charged as liquid type through the low pressure side. 12th, when refilling refrigerant, inject a small amount slowly at intervals to avoid liquid compression. 13th, the loss of refrigerant during manifold gauge removal and non-condensing gas purge shall be minimal. 14th, when injecting refrigerant, all fastening parts, such as manifold gauges, shall be inspected for leakage with a gas detector after tightening and before charging refrigerant. 15th, after completing the refrigerant charging, the leakage test should be conducted to the refrigerant cylinder. Then, the refrigerant cylinder should be capped. 16th, in the case of air conditioners, the amount of refrigerant shall be injected according to the manufacturer's manual, and the normal refrigerator shall be checked with the sight glass for the appropriate amount of refrigerant. Please check the preparations and tools for this training. These are precautions. First, be cautious of the safety because the pressure test uses high pressure. Second, the pressure test shall not exceed the maximum pressure in the specifications of manufactured equipment. Third, make sure to conduct the leakage test before and after the nitrogen pressurization. Fourth, when discharging nitrogen gas, drain it slowly at low pressure and hold the hose end firmly. Fifth, for the evacuation test, do not use the high vacuum hose that is installed to the vacuum pump. Instead of it, use the manifold gauge hose. Sixth, when finishing using the vacuum pump, always close the cap of the connecting valve. Seventh, to maintain the performance of the vacuum pump and extend its life, the method of use and management proposed by the manufacturer shall be followed. Eighth, be careful not to mix non-condensing gas when injecting refrigerant. Ninth, when handling refrigerants, be careful about safety accidents. 10th, make sure not to get burnt from the low temperature of the refrigerant. 11th, make sure to wear a safety gear such as safety goggles, long-sleeved clothes, and leather gloves.
네, 지금까지는 우리가 이제 12차 시 중요 사항과 그 주의 사항에 대해서 여러분들이 좀 저와 함께 봤습니다. 나머지 동영상은 지난번 우리 그 제작 과제에서 했던 질소가압, 진공, 냉매주입, 시운전이 좀 화면상으로는 좀 중복되는 부분이 많이 있어서 그 부분은 지난 영상을 좀 참고하시고 이 영상을 보셔도 됩니다. 그래서 좀 중복되는 부분은 이제 넘어가고 저희가 이제 그 냉매를 장치에 넣는 방법이 뭐 여러 가지가 있겠지만 크게는 뭐 제 생각으로는 한 3가지 종류가 있을 것 같습니다.
So far, we just watched about the part of the key points or the precautions of the video clip number 12. So you can just refer to the previous video clip or you can refer to the current video clip for checking the repeated contents such as the pressure test, the vacuum test, and charging of the refrigerant. And then now I would like to give you some explanation about the parts of the charging the refrigerant. So I can divide the 3 methods of charging the refrigerant.
예, 지난 과제 이제 제가 조금 아까 이제 갑자기 생각이 안 나서 말씀을 못 드렸는데 4차, 5차 시 그 동영상에서 이제 저희가 이제 질소갑, 진공, 냉매주입, 시운전 차시가 있었습니다.
So actually you can refer to the video clip number 4 and number 5 to check the detailed explanation about the pressure test, the vacuum test, and the commissioning as well.
우리가 대부분 냉동 장치들은 이제 사이트 글라스가 이제 부착이 되어 있습니다.
In a general refrigeration cycle or the unit, it has the sight glass on it.
그렇지만 그 사이트 글라스가 부착되어 있을 때는 우리가 냉매에 넣는 방법이 이제 우리가 이제 교과서적으로 말씀드리면 이제 사이트 글라스에 기포가 안 보일 때까지 이제 넣는 거죠. 냉매를 주입하는 거죠.
When there is a sight glass on the refrigeration system or the cycle, you can charge the refrigerant until there is no bubbles on the sight glass.
그 다음이 이제 그 지금 우리가 보시는 그 영상에서 보시는 이제 에어 컨디셔닝 이런 데는 이제 사이트 글라스가 우리가 부착이 안 돼 있기 때문에 그 제조사에서 이제 그 요구하는 그 냉매량을 여러분들이 넣으시면 주입하시면 되겠습니다.
And then actually in this video clip, you are going to see how to recharge the refrigerant to the air conditioning system. But in case of the air conditioning system, there is no sight glass generally. So you can recharge the refrigerant to the air conditioning unit according to the specified amount on the equipment according to the manufacturers.
To charge the optimal amount which is required for the refrigerator.
예, 지금 방금 전에 보신 것처럼 이렇게 지금 냉매가 이제 얼마큼 뭐 한글로 써져 있긴 한데 R410A를 1kg 주입해야 된다고 이제 명판에 나와 있네요.
So you can see about how to recharge the refrigerant briefly in the video clip what I just played now. So it's just mentioned in Korea, but it said that the competitor or worker can charge the refrigerant about 1 kilogram of the R410A refrigerant.
그래서 지금 좀 전에 설명드린 것처럼 냉매 넣는 방법은 이제 사이트 글라스가 부착돼 있으면 기포가 안 보일 때까지 충전하면 되고요. 두 번째는 지금 제조사에서 그 요구하는 그 명판에 붙어 있는 만큼 냉매를 넣으시면 되겠습니다. 이제 문제는 사이트 글라스도 없고 제조사에서 요구하는 냉매량도 없을 때 어떻게 이제 냉매를 넣을 거냐가 문제겠죠.
So as I just mentioned, if there is a sight glass on the unit or the system, you can recharge the refrigerant until you cannot see the bubbles on the sight glass. And then nextly, if there is no sight glass on the system, such as the air conditioning unit, you can recharge the refrigerant according to the specified amount on the equipment or the units. But there is some problem when there is no sight glass on the system or there is no specified amount on the equipment by the manufacturer.
세 번째는 이제 사이트 글라스도 없고 제조사에서도 정해준 양이 없을 때는 저희가 이제 뭐를 보고 넣어야 되냐면 관행각도와 과열도를 기준으로 넣으면 됩니다.
So in this case, you can use the last method to recharge the refrigerant. So you can recharge the refrigerant by checking the subcooling and the superheat.
팽창변이 이제 주로 이제 없을 때는 우리가 과열도를 맞출 수 없기 때문에 그 냉매량 가지고 이제 과열도를 맞출 수밖에 없고요.
But in case that there is no expansion valve, there can be no superheat and the subcooling standard. So you can recharge the refrigerant without those standard.
그래서 여러분들이 이제 팽창변이 없는 타입은 그 냉매량을 과열도를 가지고 OK가 아니라 5K 될 때까지 여러분들이 냉매를 주입하면 되겠습니다.
So in case that there is no expansion valve in the system or the unit, you can recharge the refrigerant by checking the superheat by adjusting the superheat gauge to the 5K.
관행각도, 과열도 모두 5K를 맞추는 게 가장 좋은데 이게 사실 두 가지를 동시에 5K를 맞추기는 좀 어려움이 좀 있습니다. 사실.
It is ideal to adjust both the superheat and the subcooling get adjusted to the 5K, but it is quite hard to adjust both standard to the 5K.
팽창비 다시 한번 설명드리면 이제 팽창비 없는 거는 과열도를 OK 맞추시고요.
So one more time, if there is no expansion valve, please make sure to adjust the superheat to the 5K.
만약에 팽창변이 있는 타입 같으면은 관행각도를 OK에 맞추고 과열도는 팽창변 갖고 맞추시면 될 것 같습니다.
So, and then in case that there is an expansion valve on the system or the unit, you can adjust the subcooling to the 5K, and then you can adjust the superheat by checking the expansion valve.
뭐 이게 제가 지금 드릴 말씀이 뭐 정답이 아닐 수도 있는데 이제 저희가 이제 실무에서 많이 사용하는 방법이고요.
This is not the only method or the answer to refrigerant of the charging, but in the actual workplace, this kind of a method is generally used.
뭐 어쨌든 동영상은 다 끝났고요. 여러분들 그 12차 영상 우리 12개 지금까지 하면서 오랜 시간 또 함께 해주셔서 또 감사를 드립니다.
So now it's time to wrap up all the session of the YouTube Live, and then thank you for watching and then sharing your valuable time with us by having these instructions of the YouTube streaming together with us.
코로나만 아니었으면 저도 좀 여러분 계신 쪽에 좀 방문해서 좀 같이 우리가 기술도 이렇게 나누고 했으면 좋았을 텐데 코로나로 인해서 그렇게 못한 게 매우 아쉽습니다.
So if we are not under the pandemic situation by the COVID-19, I would like to visit each countries directly to share our expertise to a lot of people, but it is a little bit disappointed under this pandemic situations.
하지만 이제 이렇게 동영상으로만이라도 어떻게 유튜브를 통해서라도 여러분들과 이렇게 소통할 수 있게 된 것을 감사하게 생각합니다.
But I still would like to give a special thanks to having this opportunity to share our expertise with a lot of people through the video clip and then the YouTube live streaming as well.
내년엔 좀 상태가 다 좋아져서 여러분들도 우리나라 한국에 좀 오시고 저도 여러분 계신 쪽에 가서 좀 만나 뵙기를 희망해 봅니다.
I hope in the next year we can visit each other's country to share a lot of expertise with each others.
그리고 늦은 시간까지 또 많은 관심을 가져주신 그 우리 SCM 로엘 그다음에 우리 부심사장 카스텐 또 그리고 지구 반대쪽에서 지금도 오늘도 들어온 것 같은데 지금 새벽일 텐데 이렇게 매번 한 번도 안 빠지고 이렇게 참여해 주신 브라질 서지오, 그다음에 뭐 반대쪽 그 이웃 국가지만은 뭐 코스타리카 국제지도위원 또 그 밖에 또 많은 분들이 관심을 가져주시고 저희 유튜브 방송을 실시간으로 봐주셔서 너무 감사드립니다.
I would like to express my appreciation to all the experts, especially for our SCM Noel and Deputy Chief Carlston, and then Sergio of the Brazil, the expert in Brazil, who can watch this video clip in the early morning, and then even the expert in the Costa Rica. Thank you, all of us.
마지막으로 또 이런 좋은 기회를 주신 또 이렇게 많은 장비와 또 이렇게 같이 해주신 우리 기술진들에게도 감사를 드리고요.
Also, I would like to share my thanks to our technical teams to offer a lot of high-tech equipment and the environment to have the YouTube streaming.
그리고 이제 마지막으로 이제 또 이런 또 어려운 이런 상황에서도 이런 기회를 주신 또 한국산업인력공단 그리고 또 특별히 HRD 협력부에 감사를 드립니다.
So lastly, thank you for the World Skill Korean team, especially HLG team, to make this opportunity to share our expertise with each others under this pandemic situations.
어쨌든 다시 한번 감사드리고요.
Thank you again.
그 다음에 저희가 다음 주부터는 한국에서 이제 전국 대회가 이제 열리게 됩니다.
And then next week we are going to have the Korean National League.
좀 축소가 될 것 같고요. 뭐 필요 인원들만 경기에 참여를 할 것 같습니다.
The whole size of the National League got just a little bit minimized. So we are only going to proceed the National League with the necessary people and the necessary equipments.
그래서 저희가 이제 예상하기로는 어떻게 이제 코로나 상황에서 우리가 이제 전국 대회를 치르고 있는지 또 그 시도에서는 또 어떤 일이 있는지 선수들은 어떻게 경기에 임하는지 이런 내용을 또 저희가 영상을 담아서 다음 주 한 이 시간쯤 될 것 같은 다음 주 금요일쯤 될 것 같은데 그때 또 아마 여러분들께 그 상황을 보여줄 수 있는 기회가 될 것 같습니다.
I think we also can have the good opportunity to share about the situation of the Korean National League in the next week, so we can share how we are going to proceed the National League under the pandemic situation, and then what happened in each skills, and then lastly how the competitors be in the competitions. So it can be the next Friday.
예, 다음 주 많이 좀 기대해 주시고요. 그동안 너무 고마웠습니다. 감사드리고 또 내년에 상하이에서 뵙겠습니다. 예, 여러분들 너무 고마웠습니다. 감사합니다.
Please be participated in our YouTube video clip about the National League in next week, and then thank you for participating all of this with us, and then I hope we can see all of you guys in Shanghai in next year. Thank you all.
땡큐 고맙습니다.